This is the first of a series of videos that are going to accompany your writing assignments in General Biology 1 lab. As with any type of writing, writing in the sciences is a way to convey information to your reader. However, in the sciences, we have a particular style that may be a little different from that you've learned in your English classes. We try to be very concise when we write. Editing is really important in a science paper and making sure that every word and every sentence conveys the most information possible. Also, in science, it is important that we have in our experiments as little bias as possible, and we also want to have that in our writing. So typically, a scientist, when they write a paper, they're going to write in third person. They're going to put as little of themselves in the paper as possible so that the science is really the star of the paper. The general format for all of the writing assignments that you're going to be doing in GB1 Lab is that you need to double space your paper, you need to use 12-point Times New Roman font, stay in third person and use the passive voice whenever possible. Write your paper in past tense. You've already done the experiment, so anything that deals with your experiment and what you did is going to be in the past tense. And finally, identify each of the sections that you're given in the assignment with a bolded heading title so that it's clear which section is which. You are going to need a title page for your assignment. Whenever you're writing titles in the sciences, you want to make sure that your title is fully descriptive. You need to describe the independent variable, the dependent variable, the study system. The reader needs to have an idea of what the paper is about just by looking at the title. But don't make your title too long. Try to keep it concise, a line or less. Also, make sure your name is on there, your lab instructor, and your lab date and time. In a full scientific paper, you have an abstract, you have an introduction, methods, results, discussion, and then the literature cited. However, in this writing assignment, you're not going to do a full lab report. What we're going to do is have you write smaller pieces of these sections. And, as you go on, you'll learn more and more about what these full sections are going to look like. So, for the aim or purpose, this would generally fall in the introduction of a lab report or scientific paper. And in this case, we want you to write, what is the aim or the purpose of the experiment? What is your experimental question? You're going to need about a sentence or two to write this out. Next is your hypothesis. Again, this would be in the introductory part of a full lab report. Now, your hypothesis is a possible answer to your experimental question, the one that you've already formulated under the aim or purpose section. Hypotheses are statements, and they should be complete sentences, and a hypothesis has to be testable and it has to be falsifiable. You may have heard these hypotheses being called educated guesses, and this is kind of true. They're educated because a scientist uses all the available information in order to come up with these hypotheses. But they're not really so much a guess if you have that much information and it's actually based on some really good science, then I wouldn't call it a guess. But once you have your hypothesis, you design an experiment in order to test this hypothesis. And based on your hypothesis, you should be able to come up with certain predictions on how your experiment should turn out. So what do you expect to see in your data if the hypothesis is supported? What do you think you might see in your data if the hypothesis is not supported? Now, of course, you can't come up with all possible permutations of what would happen in your data if the hypothesis is not supported. But, for instance, with the Daphnia, perhaps if you were saying that caffeine would increase the heart rate, when you look at your experimental predictions, then if hypothesis is supported, heart rate increases in your Daphnia. If it's not supported, then we don't actually see a change, or perhaps we even see a decrease in the heart rate. Now, this section is the one that's going to be most like a full lab report. In a full lab report, you would have a methods section, just like here, the methods or procedure section. And we're going to actually have you write this out because you guys design your experiment, so you should know exactly what methods went into it. So when you write out a methods, one of the keys is that you have to give enough detail that another competent scientist could repeat the experiment. But you don't need to give unnecessary details, and this can be something that it takes a little while to learn exactly what should be included and what shouldn't be included. You need to let the other scientists know things like, what kind of equipment did you use? Tell them what concentrations of chemicals you used. If you told someone that you treated Daphnia with caffeine and saw this result, they really can't repeat the experiment unless you tell them what concentrations of caffeine you treated them with. On the other hand, you don't need to give them unnecessary details. We see this a lot, people writing, get a clean beaker. most good laboratory scientists are going to know to make sure that their beaker is clean when they get it, so you don't really need to say things like that. Assume that the scientist you're talking to can do the basic laboratory procedures. So you don't need to tell them how to make a 5% caffeine solution, but you do need to tell them that they need a 5% caffeine solution. While your methods section might be longer than a full lab report, in this case it's only going to need to be about one page composed of one paragraph. Make sure it's in complete sentences and written in past tense. Do not cookbook it, and what I mean by that is do not put down step number 1, do this, step number 2, do this. While it may be very useful in your notes to write that out, so you write that out so you can organize your thoughts, when you actually write the methods, you don't do it in that manner. One of the most important things to do in the methods, though, is to make sure that you do organize your thoughts so that you tell the person how to do the experiment step by step in order so that they can follow the same steps and make and repeat the experiment. The next section of a full lab report would be the results section, and we're going to have you write an abbreviated results section for this writing assignment. This is the section where you present your data. You've run your experiment, you have data from it, so you're going to present it to the world in your paper. It has 2 parts usually, and that's the data that you give in graphs and figures or tables. Graphs, of course, you know what those are. Figures are going to be your pictures. You might have microscopy images or something like that in there, and then tables. Also, there's a second part that is a narrative, so there's a written part in the results, and that presents and describes your findings. It does not discuss why these findings occurred, it just says what has occurred in your data. For this lab, you're going to be creating a bar graph, and you have 2 options on this. You could take the averages of the heart rates for each treatment for the entire class data set. So let's say that every group in the class tested 1% ethanol, 2% ethanol, and 3% ethanol. You take the heart rates from all of those different groups, you average them out for the 1%, you average them for the 2%, you average them for the 3%, etc., and then you graph that in your bar graph. The second option is to take in the account that every one of these Daphne is going to have a different base heart rate. Just like in humans, some of us have high heart rates when we're resting. Some of us have low heart rates. The Daphne aren't going to start out all at the same point. So what you can do is look at the change in heart rate. So you look at the base heart rate, you look at what the heart rate is in the treatment, and then you look at what the change is. And in that case, you're going to look at the averages of the change in heart rate. Regardless of which option you choose, you must add standard deviation error bars to your graph. You may be wondering why you need to add standard deviation error bars to your graph. Well, when you calculate a mean from your data, not all of those data points that you're looking at are going to be close to the mean. They're going to be spread. There's going to be some variation around that mean. Standard deviation gives you an idea of how spread out your data is. Now, if you have a very tight standard deviation, then most of your samples fell pretty close to that mean. If you have a pretty wide standard deviation, then, a lot of your samples were kind of scattered around that mean. Your graph should be black and white, do not have any color in it. Your x-axis and your y-axis must be labeled, and they have to have units. And make sure that you put an informative title under the graph. Remember that the x-axis is where you're going to put the independent variable, and the y-axis is where you're going to put the dependent variable. Now we want to spend a little bit of time about how you're going to graph these in Excel. This is one particular version of Excel. Your Excel may be a different year, and if your Excel is very different from this, you'll probably want to go to a computer lab and get some help on this. But this should still give you a decent idea of what you need to do. So here in Excel, we've set up some columns. The first column represents our independent variable. It's our ethanol concentration. You can see that we have 0, our control, and we went 0.5, 1%, 1.5%, 2, so on up to 3%. We've got a blank column here, and the reason we did that is we're going to put our average heart rate into that column, and then the next couple of columns represent the change in heart rate for different groups in the class. Now, you may not be doing the change in heart rate graph, but the same idea works. Put your different groups' data into different columns in your Excel. Now, do remember though, if you're doing a change in heart rate, that change may be positive or negative. If heart rate goes up, it's going to be positive. If heart rate goes down, it's going to be negative. Once we have our Excel sheet set up, what we're going to need to do is get the average or the mean of the change in heart rate. So we're going to go to our Home tab over here, All right. And then on the Home tab, you should see a little thing over here that says Auto Sum. We're going to click down on that and we're going to find Average underneath that. Okay. We're going to click on the average. And when we do that, we should see something like this appear over in the cell that we have highlighted. As you can see, it says equal, and notice this equal sign. In front of every formula in Excel, there's going to be an equal sign. If you don't put that equal sign, Excel doesn't recognize it as a formula. So we have a formula equal sign, average, and in parentheses, we have the range that we want to average. So in this case, we want to average group 1, group 2, and group 3. Group 1's data is in C2, group 3's data is in E2. So we're going to go from C2 colon E2. That's going to do the whole range between C2 and E2 for the average. There are a couple of different ways that you can have this happen. You can either highlight C2 through E2 and it'll automatically write out the formula for you, or you can actually type in what we see right here. Now, when you've done that formula and you hit enter, what it should do is it should pop up the average. Now, if you know your Excel, you know that you can go to this little corner over here, and what you'll see is that your pointer will change and it'll look like this. When it does that, you can click and drag that little pointer as far as you want. See here, it's been taken down to here. And when you drag that, it's going to drag the formula all the way down, calculating the average for each one. So give that a try. If that doesn't work for you, you can always go in and actually repeat the process for each one of these and get your average. But this is kind of a shortcut way to do it. Once we have our averages, we're going to add in our standard deviation. So again, we're going to go over to our little function bar over here, but this time we're going to look at more functions. When you click on more functions, it should bring up a box like this. Now, more than likely, you're going to see a list of common functions underneath it, and standard deviation should be on that list. But if you don't see it there, what you can do is you can type in STDEV and it will search for it for you. When you get to the standard deviation, I'm not sure if your Excel will do this or not, but do not let it highlight the entire row from A2 to E2. Only highlight your sample. So in this case, it would be C2 to E2. Remember, group 1 is C2, group 2 is D2, group 3 is E2. So if your Excel tries to highlight all of them, make sure you don't let it. You go in and you either type or highlight yourself just the group data. Once you have your standard deviation in your first cell, you can use that method that we talked about clicking and dragging to fill in the rest of them. So put your cursor over in this corner, wait for it to change to look like that, and then just click and drag down to the rest of the cells that you want the standard deviation in. Or you can do the standard deviation process for each one of those cells individually. And here is our finished table set up. So we have our ethanol concentration, which is going to be our x-axis in the first column. We have our average change in heart rate, which is going to be our y-axis. In the second column, we have our group data, and finally we have our standard deviations for each of the ethanol concentrations. Select the ethanol and the average change in heart rate columns. At the top of the screen, we're going to choose Insert, and we're going to go over to where the graphs are, and we're going to choose a 2D column over here. Alternatively, you may choose the recommended charts, and one of those that pops up, in fact, the first one that popped up on my particular version of Excel was the clustered column. That would work as well. Now, something like this may pop up, but it's missing quite a few of the things that we need to see on our chart. So we're going to go in and we're going to add the remaining materials that we need, and we're going to take away some of the things like these lines shouldn't be on there, and we are going to remove them. If you look at the top under Chart Tools, you'll see Design in a Format tab. We're going to go to the Design tab, and over here on the far left, we're going to see Chart Elements. We are going to choose under Chart Elements Axes, and we're going to do the primary horizontal first and the primary vertical, and we're going to use these to label our X and our Y axes. And when we go in, right now we are doing our vertical axis, and that one is right here. And it's going to pop up, and it's going to let you type in whatever you want to put in that particular axis. So go ahead and do that. Remember that you have to have your units. So in this case, we were doing heart rate and beats per minute, so we make sure to put our units in there. All right, I guess the other one, we did our vertical axis already, so let's go ahead and go back, repeat the process, and add in the horizontal category axis title. In this case, it's ethanol concentration. So we're going to go ahead, type that in. And here you can see that both of our axes are labeled. Also, you'll notice at the top, it gave a chart title. That's not what we wanted, so we went ahead and selected that and deleted it and removed it from our chart. Next, you're going to click on these lines so that you can actually see they're highlighted. See these little spots that indicate those lines are highlighted? Click on that and hit delete, and that's going to get rid of the grid lines. And here is our chart with no grid lines. Notice at this point we have our axes labeled, we have no grid lines, but we still have a border, which is something we also need to get rid of. One thing that you might want to do, and I did it on this one, was I actually selected the axes labels up here, and I bolded them and made them a little bit bigger so that they were more obvious to the reader. Now, you might remember the standard deviation that we did, and we were going to put that into our error bars, and here's how we're going to do that. So go back to your chart tools, again, design, and we're going to go under chart elements. Under the chart elements, you'll see the error bars, and I want you to choose the more error bars option. When you do that, you're going to see this pop up over on the side, and I want you to choose the custom down here. When you do that, you're going to see this box pop up. I want you to choose this little box over here. When you select that box, it's going to allow you to go over and click outside over here to choose a section. I want you to highlight this entire standard deviation row, get all of the cells that have standard deviation in them. And when you hit enter, you should see that there's now a value in this first one. It's going to indicate the cells that you selected. Do the same thing for the negative error value. Select it and then go and highlight all of the standard deviations. When you do that, you should see error bars, and notice the error bars are not all the same. They are of different sizes. That's because the standard deviations weren't all the same. If all of your error bars are the same, probably something is wrong because your standard deviations probably aren't the same across the board. Just a few more formatting issues. This is supposed to be a black and white graph, so you're going to go again to Chart Tools and Design. You can go to Change Colors, and when you do that, you can scroll down to the black. All right. Here is our graph. It's now in a black and white, or grayscale in this case. So now we're going to go and we're going to do one more thing, and that's to get rid of the border. So you can see that I've clicked on the main chart, and then I did a right click on that, and we're going to choose Format Chart Area. When we choose Format Chart Area, one of the options we have underneath this first one with the little paint bucket is our border, and we're going to choose no lines so that we remove the border on the outside. When you do this, your graph should be formatted correctly as it is. However, you will notice there is still no title. So what you're going to need to do is you're going to select this, copy and paste it into your Word document. When you get into your Word document, go underneath this figure and type figure 1 and then give it a fully descriptive title. Don't forget that your results have to have a second part, and that is the narrative part. So in this part, you have to have text that describes and highlights all of your important data. So you're going to want to look at figure 1, pull out the most important trends, and verbalize those trends for your readers. You always refer to the text in the text to all tables and figures. For example, in our particular figure, we see that as ethanol concentration increases, diaphnea heart rate or change in heart rate decreases. If we were going to say that in the text, we would then say figure 1 behind that in parentheses to indicate that they could look at figure 1 to see the data that supports what we just said. Now make sure that when you're doing the results, you do not draw any conclusions. Just report what happened, not why it happened. Conclusions and whys go into the discussion section of a paper. Now, for the last part of your writing assignment, you're going to do your conclusions. This is not like a full discussion that would be in a lab report. However, it is a couple of important things that do fall under the discussion heading if you're going to write a full lab report. One of the most important things you're going to do is say whether or not you supported your hypothesis. Compare your results to those predictions you made based on the hypothesis and say whether or not you supported your hypothesis or not. Don't repeat your data. Don't go in and say, diaphnea heart rate changed by 2 beats per minute at 0.5% ethanol and changed by 0.4 beats per minute at 3% ethanol. Don't say exactly what they were. Just summarize some of the key points that came out of your results. Also, think about, are there any variables that you could not control that might have affected your results, especially if maybe your results didn't support your hypothesis. Was there maybe something that happened that could have affected your data? And address all of this in a short paragraph.